So good evening, everyone. Thank you for joining us today. On behalf of Zeliot, I am excited to welcome you to this special session focused on connected mobility, or maybe in precise real-time data transformation. So today, along with our partner, iTriangle, will show you what it takes to go from raw data streaming to operational decisions. Not in theory, but we'll do it live. So iTriangle is the largest Indian telematics manufacturer. Zeliot with iTriangle have been working since a long time in the automotive space, especially in the Indian region. In fact, iTriangle with its cutting-edge telematics devices and Zeliot with its data streaming platform have empowered large commercial OEMs in Indian context. So now I have Mr. Badaraj Katti, CEO, Managing Director of iTriangle, to enlighten us about iTriangle and its products. Over to you, Mr. Katti.
Hello all. Thank you for being here in today's webinar. So as Panchakshari mentioned, and thank you Panchakshari for doing the opening remarks. As Panchakshari mentioned, iTriangle and Zeliot have been working very closely over the past few years to deliver immense and critical value to their customers. So while from iTriangle's point of view, while designing and developing the devices, we have incorporated Zeliot's Condense platform requirements, and Zeliot too has adopted the iTriangle's ecosystem. This partnership has been, has proved to be of great benefit to its customers and industry in general by delivering data hygiene, data stability, the efficiency, speed, and more importantly, reduced cost of ownership. So what I'm going to do in the next few minutes is I'm going to talk to you about iTriangle, what we do, the kind of devices and we have, and then what have we done to break away from the clutter and then give more value in our devices. So hold on for a second. I'll just share the screen. So yeah, so as I mentioned, iTriangle has been, focusing on designing, development, and manufacturing of transportation telematics devices. Our basic objective always has been to enhance road safety, improve lives, and then drive enterprise productivity and efficiency. So in that sense, today we have more than 2.5 million devices deployed, predominantly in India, but a few in Middle East, Africa, and Southeast Asia. And then we have been around for the last 16 years. We have done ground-up design and development. And then it's been always our objective to deliver and innovate and optimize and deliver our three cornerstones on which we have built our business. So precisely, when you look at it, this is what we do. Like while we design, develop, and manufacture devices, the output that we focus on is driver behavior monitoring, insurance telematics, integration with IoT, vehicle diagnostics and management, vehicle tracking and fleet management. We work with, we are a holistic telematics company. We address electric vehicles needs, compliance telematics. Various countries in our region have compliances around this, technology. And then we work very closely to develop cutting edge compliance telematics devices, asset tracking, customized solutions, remote monitoring and control are the few of the things that we do. So when you look at this circle, which essentially gives you the philosophy of iTriangle, we have tried to be a holistic telematics company. We serve almost all verticals of transportation telematics, starting from aftermarket to automobile manufacturers, electric vehicles, public passenger transport, fleet management solutions, insurance, and even battery management for electric vehicles, which is very critical for the efficiency of the EV industry. So when you look at our business landscape, as I mentioned, we have been a holistic telematics player. We have devices for almost all use cases of transportation telematics. So as a philosophy, whenever we design and develop a device, we try to identify the sector. We work basically in these sectors that you see on the screen: compliance telematics, OBD telematics, basic telematics, advanced telematics, OEM specific solutions targeted to automobile manufacturers, two-wheeler manufacturers, and things like that. And then, of course, the ADAS based solution, which is now the most emerging thing in the market today. So with these devices, we try to address all the sectors: mining, enterprise, auto manufacturers, global markets. We have deeply penetrated to the Indian market after we launched our devices or our business by 2016. But now we are now eyeing global markets. We want to be very dominant in Middle East, Africa, Southeast Asia, and even in the US. So logistics, enterprise. So as I said, we try to touch point every use case of transportation telematics, and that has given us a ringside view of the requirements that are there. And with that in mind, we try to develop devices that provide you immense value as you give your business offerings or your total offerings to your customers. Some of the tech-enabled data points, location, speed, accelerometer, harsh driving, odometers, CAN parameters, and then through the sensors and through CAN, we do fuel level, we do temperature, we do tire pressure, ignition related data. So some of those critical points that we do, and then we do it very well. That's what you will see when you start using our devices along with Zeliot's platform. Unique offerings, one of the unique offerings that we have, especially which is useful to automobile manufacturers, two-wheeler manufacturers, and even to a few enterprise customers is we have developed a module called Vehicle Photo, which is called as Aquila Edge, which in very simple terms enables the auto manufacturers or the two-wheeler manufacturers to upgrade the vehicle ECU, debug or flash a new firmware or a new software over the air without having to recall the device, the vehicles back to the garage. They create campaigns remotely and then and upgrade all these ECUs and then debug whenever necessary. This actually enhances user experience and reduces costs, reduces operational costs, and then it actually increases the value proposition to their customers. This is one of the few modules that we have developed, but then there are quite a few that has helped us to break away from the clutter and then give some kind of a USP to our partners. So as we talk about telematics, one of the important things that we do really well is basic track and trace, driver behavior analysis, geofence, and things like that. But along with that, we virtually treat our device as a black box that sits in a vehicle and sends some real-time information on some very, very critical data points. So these critical data points include those that are reported from the vehicle, plus what we can derive out of our edge computation that we do on our devices. For example, that what you see on the screen is trip distance odometers, fuel consumption, oil pressure, coolant temperature, hose speeding, and then from ROCAN, we get the vehicle speed, seat belt indicator, accelerator pedal status, drive with handbrakes, so on and so forth. So what you essentially see from these kind of data that we are showing it to you is we focus on delivering cutting edge solutions, cutting edge devices that actually helps you to serve your customers in a way where the customers can not only improve the business efficiency, but also, improve their bottom line, improve their return on investment. So that is very critical because as we go about offering our products to our customers, we feel that it's not a commodity that we are delivering a value, we are delivering technology. And in that sense, we would like to, be a partner with you and then help you essentially to get all these kind of values that you actually aspire to deliver to your customers. So I'm sure this is very briefly about iTriangle. There are a lot of other things. We encourage you to visit our website and then know more about our devices. We are always there to touch base with you and then partner with you and then increase our business. And I'm sure Panchakshari will have more to say on how the Zeliot and iTriangle association will be of critical and technical even value to all of you. Thank you so much. And over to you, Panchakshari.
Thanks, Mr. Katti, for providing us the insights on iTriangle. I'll take over from here. Before we jump into building an actual pipeline or realizing an actual use case, let me talk a bit about data streaming platform by Zeliot, and let me set the context for it. So today, when we talk about vehicle data, what we really are talking about is data streaming. whether it's the location information, whether it's the vehicle telemetry data, the diagnostic information, the alerts that are getting generated from the vehicles, etc. So now, building real-time system sounds very simple in theory, but in practice, it usually means stitching together a lot of tools, especially Kafka for streaming, and then a couple of stateful logics, APIs for handling the gateways, and of course, monitoring tools, something similar to Prometheus or Grafana. And for being agile in this modern world of changing technology, the CI/CD pipelines, etc. And it pretty much adds up too quickly to create an ecosystem to manage. So that is precisely why Condense was built, and that is the gap that we are trying to solve in today's modern data streaming world. So Condense is a Kafka native real-time data streaming platform. It's fully managed, it's cloud agnostic, and it's specially designed for teams to focus on outcomes, business logics, not worry about the resources, the infrastructure underlying to it. Instead of managing all the separate blocks, Condense gives you one unified platform, Kafka, which is built in and is fully managed for you. Pre-built connectors and transforms which could plug in directly with simple configurable parameters, and which could essentially aid in decreasing the time for GTM. And there is a space where you could visualize the pipelines which you have created, and also not being said, the observability is very native to Condense, where you will be able to monitor all the underlying parameters, all the underlying infrastructure, scale up, scale downs, messages which are coming in, messages going out in one unified dashboard. And all of this on the customer's cloud, where we specifically bring in a concept called as BYOC, bring in your own cloud. So when you run Kafka completely inside, where you can run Kafka completely inside your own Azure subscription, the AWS subscription, and the GCP subscription. So why does it really matter? When it comes to data sovereignty, especially in this world of geopolitics, where data has become a very essential part of critical decisions, data being inside one's own cloud gives a strength to use this data in however the fashion that is required. And also it adds up a couple of more advantages like billing control, and then you could easily retire the quota that the cloud provider offers. And one more aspect, which is the very essential core aspect of Condense that I'm going to highlight now, is the vertical focus or the domain-specific intelligence that Condense brings into picture. Condense isn't just another generic data streaming platform. Condense houses a lot of domain-specific intelligence, especially when it comes to mobility, industrial IoT, mining, other sectors like manufacturing, etc. So, getting a little deeper into mobility, connectors for telematics devices, the one that we are talking today, like the iTriangle telematics devices, and then connectors to OEM connected mobility platforms. Uh, Ready to use application logics like geofence alerts, harsh braking alerts, panic alert detection, periodic data publishing, CAN decoding, etc. So all that is domain specific intelligence that is pulled out from the telematics devices and made real sense of. And of course, you push this data into more visualization systems like the fleet management system, the transport management system, and for later analysis to a database and things like that. So this essentially means that you have to really use very minimal low code or no code environment and deploy these connectors and fast track your GTM. So you pick the components, just add a couple of configurable parameters, and the connectors are ready. And these are fully managed in nature, so that there is no manual intervention that is required whenever there is a load that gets added onto a platform, especially in this world where systems are connected and a lot of connected devices are communicating to the backend platform. So, in today's case, we are trying to cover one of such similar cases where we'll be able to establish connection with a telematics device. We'll be able to transform this data or parse this data into a real readable format to the other applications that are available. So we are trying to realize a geofence alert mechanism or an alert transform, which triggers an alert, and that is eventually pushed to a database and of course to a fleet management system. And from the fleet management system, based on the geofence breach, there is a communication back to the device for mobilizing the device. So basically, this is on a context that if there is a theft, and theft of a vehicle, so and the specific geolocation is assigned to that vehicle. So immediately, whenever there is breach in geofence location, the entire platform with the fleet management solution facilitates that risk to be mitigated. So let's quickly jump onto building the real pipeline itself. So I have Nitra with me who will help me in building this pipeline. So Nitra is from Zeliot customer success team. So let's get onto the platform and start building the real use case that we are talking today. So Nitra, if you could bring up and share. Yeah. So this is the login page of Condense. So of course, Nidra is already a registered user here, so she can directly log in. But if you're signing up for the first time, there are a couple of other parameters that are that the platform asks you to input. So now, as soon as we log in, we land onto a page called as workspaces. So if you see, these are workspaces. Basically, these are different use cases that are realized. So you can see that there's a fleet management system. There are other use cases which are pushing data to Redis and things like that. And now let's get on to the settings page where we'll be able to really understand how Condense brings the RBAC structure into picture so that you really can segregate those workspaces and assign roles and then give specific credentials to specific roles. So you could see that there are a couple of admins here, there are users, so that you can really categorize who works on this platform and who can be a person who can view the platform. And if we go a little higher, there is something called as Git connection. So I'll come back to this at a later stage. But right now, let's assume that it's just the connection that is required. So Netra has already connected her Git to the platform. And now let's go back to the pipeline. So you could also see that, Netra, if you could just go back a little and go to one of the use cases, maybe we can explain a little more about what are the features that Condense hosts. So just click on fleet management system. Very good. So if you see that on the left hand side, there are pipelines where you can visually see what kind of pipeline that you're building, and also it's easy to navigate where you can understand what kind of logs are generated by clicking in the transforms, by clicking on the connectors, and ultimately the output connectors as well. So if you see on the left hand side, there is a page called as connectors where you would be able to visualize both the connectors that you have built by yourself as well as the pre-built connectors which are low code as well as very very minimal code kind of code transformations or connectors. And then if you come down a little, there is something called as utilities. And then when you navigate from the left side to the applications page where you can really understand what you could build through the custom transform framework. So what essentially is a custom transform framework is the full code environment. So Condense brings in best of both worlds of the low code and no code environment, as well as the full code environment where there are proprietary logics written so that essentially it could handle the customer by for bringing in both things. So now let's quickly jump on to building the application or building the pipeline itself. So yeah, so it's already so there's a pipeline that has already there's a workspace that is already created called as C2D. So the naming is simple. It's just that cloud to device and device to cloud. So it is that kind of communication. Typically, it is device to cloud, but since we are also triggering some kind of actions to the device. It is named as C2D. So if you see here, there is already a telematics device that has got added, which is one of the iTriangle devices called as TS101. So here, if you see, the configuration parameters are already configured. Specifically, this is done because once this connector is deployed onto a platform, it generates an IP port which is pre-configured. So Netra, if you go back and showcase that, then it will give an understanding. So you just go to connectors and then add one of the iTriangle devices here. So you see that there are a couple of iTriangle devices which are already parsed with respect to protocols. So now you could see that there are very minimal configurations that are required. So all of the raw data, complex data that is coming from the device is parsed by this. So once this is done, it essentially gives an IP port which should be configured on the device. So now you see that it gets deployed, and this connector is fully managed, and it is ready to be used with the telematics device to parse the data and essentially use that data into the other transformational logics. So now let's delete this and proceed with our usual case that we have planned. So this I wanted to help you visualize how easy it is to deploy this connector by giving in very minimal parameters. So now let's start building on top of this. So let's now we there is a telematics device which is sending data to the platform or the IP port that is mentioned in this. So you could see in the logs that the telematics device is sending information. So there are a couple of informations like the location information, the CAN related information, the vehicle telemetry related information, etc. So now let's go back and then start building the pipeline. So now this data is being pushed onto so the data that is coming from the telematics devices is usually of uh, two natures. The one is with respect to the event data, the other is with respect to the periodic data. So now we are focusing today on the periodic data, and of course we'll take the event data, we'll segregate the event data and leave it behind. So Nita, you could continue and start putting the information related to periodic data. So underlying there is this transformation is working with Kafka. It is deployed on Kafka. So there are different credentials that are required related to the broker, related to the username, password, etc. And also what this essentially the transformation essentially does is segregate the data that is coming from the telematics device and pick only the periodic data that is coming. So basically, as I mentioned earlier, the nature of telematics device is to send events as well as periodic data. So here we are only picking periodic data because that is relevant to our use case today. So now you could see that as soon as as soon as it is you give couple of configuration parameters. Now the system is consuming data from the telematics TS101 connector, and then it is being published onto a topic, and that is being consumed by the periodic transformation. So you could click on logs and probably showcase that only the periodic data is being parsed with respect to this connector, and the event data is left behind. So you could see that the data relevant to periodic information is captured here or is being parsed here. So now let's go back and start building the data on this, start building transformations on this periodic data. So so now we could push this information onto a database. Essentially, that is where you could use batch analytics for analyzing the data at a later stage. So now the database that we are using here is PostgreSQL. So the data that is being passed by the periodic connector or periodic transformation is being pushed onto a PostgreSQL. Of course, there are a couple of credentials that are required for you to use the PostgreSQL. So here the schema is already predefined, and we are pushing this information according to the schema into the database. So the periodic data is being published onto the database from in the future. If there is a need for doing analytics on batch data, so you could pull in data from this database and essentially bring out analytics so that it could eventually drive operational excellence into the system. So you can see that the similar configurations that we did for the other transformation are brought in. And as you can see that we are also giving configuration parameters related to taking data from one topic and publishing data into the other topic. So you can go ahead and configure and publish Netra. So now you could see that the data is being pushed onto PostgreSQL database. So you could show the logs. Yeah. So now you can see that the logs are being published. So this schema is being pushed onto the PostgreSQL database. So now let's jump into creating the remaining part of the pipeline. So Nitra, you can go ahead and select the connector that we were talking about with respect to geofence. Yeah. So now we have what I was talking earlier with respect to the low code, no code environment. So we utilize the no code, low code environment till now, where we were able to configure a couple of parameters and we publish these connectors or transformation onto the pipeline. So these are fully managed in nature. And the other important aspect that I was talking about was the full code environment, where the applications feature comes into picture. So this is where I mean in the initial phase where we saw settings page where Nitra connected the Git. So this is where it comes into picture. So Nitra, if you can go to Git, so usually it is like you connect you bring in a version management system to understand what kind of version changes that are happening onto an application or onto a logic. So Nitra can continue actually. So so the Git is connected here, the linking is happening, and she's selecting one of the repositories and the branch that geofence alert is there that we have already written as part of the logic. So this is being linked and the code is being pulled onto Condense. So what essentially happens here is the custom transform framework that we call, which is part of Condense. So that is where you can build in proprietary logics. So the low code, no code environment usually handholds the customer into his GTM journey for almost like 60-70% based on the maturity of the pre-built transforms. But for that 30% of the additional journey, the customer usually has to write proprietary algorithms. That is where he'll be able to differentiate from the market. So you could see that the system, the code from Git is being imported onto Condense. So essentially, there are a couple of parameters with respect to deployment. There are a couple of files like the Docker files where you will give information related to deployment, and then the logic itself where there is transformation that is happening. And Nidra, you could go ahead and publish the application and start using it. So here you could see that there is a name that is required, and then the version. So now you could see that the application is getting built, and there are a couple of, I mean, you could also see that there is a logs section where you can see what is happening with the image that is getting built. So essentially, it's like you bring in the logic. The logic hoses a couple of things here. So detecting what the data is coming from the telematics device. So we have segregated the data that is coming from telematics device into periodic data, and that periodic data is being consumed by the geofence transformation. So this is where the comparison of the location information that is coming from the telematics device and the pre-configured location information that is there in the database, in the Redis database, which is essentially pushed by a fleet management system. So usually it's like the fleet management system, in the fleet management system, you configure the geolocation, right? So that is where you mark the boundary that is associated to the vehicle. So once that association is done, that information is pushed onto a database which is present inside Condense. So essentially, this configuration parameter, which is the geo fence that is there on Redis, and this geofence application or transform uses this information to understand whether the geolocation that is coming from the telematics device is inside this fence or it's outside this fence. So now you could see that the logs are getting printed so that you really can understand what is happening. So this information is related to the build or the image creation. So where we get unique ID for the image so that we could manage the overall operations of this application. And one more essential part that I will talk about is the fully managed nature of these applications that we write using custom transform framework. So what happens when you build the logic inside custom transform framework? These are event-driven microservices that you write inside custom transform framework, where these are fully managed in nature. So as soon as you deploy this onto a pipeline, um, Condense as a platform takes care of managing this application through the entire journey of the lifecycle. So including building phase till the deployment phase and the maintenance phase. And when inside Condense, so these are fully managed in nature so that it can handle the load that is coming as part of the input connectors. Yeah, now you could see that the application is getting built. So let's give in a couple of minutes. Usually this takes some time because there is an image creation that is required, and it is done according to the environment of Condense. Of course, when we compare the time that is required to essentially build this, it's very small. So now you could see that there are environment variables that are created so that this connector could be used, or this transformation could be used at a later stage. So this brings in a lot of flexibility when you are when you are working as a team. So you allow other colleagues to participate in building phase. So that is where you create a transformation, and this transformation is governed by a couple of low code or no code environment variables. So you allow your colleague to bring in these configuration parameters and start using the application transform. So with respect to this geofence transformation, there are a couple of configurations. As you can see that there is input topic, there is publish topic, which essentially the geofence transform pushes information to and consumes information from the input topic. Yeah. Yeah, there are a couple of transformations. There are a couple of configuration parameters that are required in order to publish information to the database, because essentially we will push this information into a Postgres SQL database so that we could utilize information at a later stage to derive any analytics that are required. Yeah, you could see that there are similar configurations that we did earlier for pushing information onto the database, and also since these are event-driven microservices, these require credentials related to Kafka, because they are ultimately consumers who are consuming information from the Kafka topics. Yeah, and the one that I spoke about, the Redis configuration, where the geofence is actually stored, and this application logic uses this credentials to get information of the reference geofence, so that it could eventually compare the information that is coming from the telematics devices and generate alerts. So yeah, so you could give in information related to the version. Yeah. So now you could publish this. I think, yeah, now you could see that since we had utilized this, so there is an alert that got generated because we had utilized the name, and there are no duplicates that are possible here. So that is one of the check mechanism that is required. So now you could see that as soon as we change the name, so the geofence alert as a transformation got published. So you could see here all the transformations that are pre-built by Zeliot are there as part of pre-built connectors, and the application logics that are built as part of the customer are there in your connectors, so that there is a differentiation with respect to using pre-built connectors and the connectors that are built by the customer. So now let's go ahead and use this. As you know that we had declared these, so now we are utilizing the geofence alert. So as you had seen earlier, so we had created couple of environment variables where it was required for the geofence as a transformation. Now we are filling in that information so that we could essentially utilize the environment variables and pick necessary information from the surrounding system, like the Redis database, like pushing information onto a PostgreSQL from the Kafka topic to sense the telematics data that is coming in. So yeah, so let's input this information. Yeah, so you can see that the credentials of the database are being inputted. Yeah, these are similar configurations basically, because underlying you are publishing to a database, and the credentials required for pushing or retrieving information from the database are required. And then also, since the underlying platform is built on Kafka topics or Kafka as a core technology, so the credentials required for consumers or producers are the basic informations like the broker and then the username and password. Okay, now let's deploy this. So you could see that the periodic data is being pushed onto geofence alert. And this geofence alert based on configuration is ready. And since it is consuming from the topic that is being published by the periodic transform. So now let's go ahead and see the logs. So you could see that it is showing as, yeah. So there are logs that the geofence alert as a transform is generating, so that you get an understanding of where the actual vehicle. Since this is simulation data that is there on bench, so most of the things are with respect to static location that are being generated here. So let's go back, Nidra, and then let's build on to the future pipeline. So now let's push this data into a database. And eventually, we also push this information onto fleet management system, where you can really visualize the visualize the fleet management system where this information is being pushed onto. That is where all of the activity happens with respect to the customer. So this Condense as a platform is a backend platform which does all the heavy lifting, which does all the hardcore job of managing the data streams and managing the scale. All of the data management related aspects are handled in Condense. So this eventually is being pushed onto fleet management system where the actual operational work is being done. Yeah, so as I mentioned earlier, similar kind of configurations are done here as well. So this geofence alert information is being published onto PostgreSQL. Yeah. Yeah, you could see that the geofence alert information is being pushed onto PostgreSQL, where at a later stage you could get this information from, and then essentially, I think that it was highlighting that the credentials are wrong. Yeah, so I guess it was not refreshed. So now you could see that the information is being populated. So the geofence alerts are being pushed onto the database. So later you could retrieve and generate analytics out of it. So now let's get on to publishing this information onto a Kafka topic. So this Kafka topic is being listened by the external FMS system that I was talking about. So yeah, so this is a Kafka to Kafka connector. So essentially, it's like the fleet management system, which is listening onto a Kafka topic, is being bridged by another Kafka topic. So usually this could be achieved by multiple ways, like you could publish it as part of an HTTPS connector, which is also a pre-built connector as part of Condense. And also it could be published as part of Kafka, as part of MQTT. And if there are external systems outside your VPC, Condense offers in security mechanisms which could eventually be used so that you could also push this information onto an external topic which is outside the VPC. So now you could see that the transformation from Kafka to Kafka topic is being done. So this information will be pushed onto the external fleet management system. So there is a pre-built connector which pushes this information by consuming from the Kafka to Kafka connector or the transformation, and then eventually it pushes this onto onto the broker ID of the Kafka topic, which is listened by the fleet management system. So we'll get onto the fleet management system as soon as this configuration is done, so that we could visualize that periodic data as well as the geofence alerts that are coming in. Yeah, configurations related to input topic, output topic. And now you could see the SASL username password also being inputted. So similar kind of configurations go into all the things that are variables. So all the heavy lifting that is done by these connectors or transforms and very simple logics or configuration parameters which are required here. So now, yeah, configurations are being done. So this is the Aquila track connector, which which is essentially pushing the information to the fleet management solution. The target topic, and then the Kafka username, the password. Yeah. Let's give in a couple of seconds to Nitra to actually fill in this information and then publish it onto a deploy it onto a platform. So now you can see that the pipeline from ingesting the data from a telematics device to essentially generating or segregating the information which is coming from telematics device into a periodic data and an event driven data, and then essentially pushing this information onto a database, and also the other stream which is consuming this information and generating geofence alerts, and that is being pushed onto the database and also onto a fleet management system. So Nitra, let's also try to bridge the periodic data onto the fleet management system, so that you also get an understanding the data that is available, the location of the device, and information that is essentially pushed by the device onto fleet management system. Yeah. So now we are considering input topic and the output topic. So now it's configured and deployed. So yeah, let's go to the fleet management solution and showcase the data that is being pushed onto the fleet management solution. Yeah, go to it. Now you can see that. Let's go to either the dashboard or reports where this information is being published. I guess, yeah, the logs are visible as part of the geofence alert. So there are a couple of devices here which are think the range was not selected properly. Now let's select the range so that we can see the recent data that has come from this telematics device. So now you can see that the data is being generated. So this is the periodic data that has got generated from the telematics device. And also, I think, Mitra, we could see the in-out information that, yeah, you could see that there is an alert that has got generated. So these are a couple of mechanisms where you could understand how the information is being pushed from the telematics device. So yeah, so essentially you can see that a complex logic, like understanding whether theft has really happened based on the assigned geofence for the vehicle. We are able to understand it with pre-built connectors and custom logics within probably less than 30 minutes or 45 minutes. So let's go to the pipeline, Netra. So now you can see that we have realized a use case where the data is being ingested by the telematics device connector, and then it is transformed into a nature that is required onto a fleet management system, and also transformed into a nature that is being pushed onto a database for further analytics. So this complex logic being realized by the best of both worlds, combining the best of both worlds that Condense offers. So the pre-built no code, low code environment and also the fully codable environment that Condense brings into picture. So what blocks that you can essentially see here are fully managed in nature. So here you are just seeing one device that is pushing data onto Condense. But in practical scenarios, there will be hundreds of thousands of devices which are pushing information, and that is where the data management part of Condense kicks in and then manages the data based on load, based on all the parameters that are required, so that even the costs are optimized. So whenever the load hits, the resources are scaled, and whenever the load comes down, the resources are being pushed down, so that even the costs related to data management are being optimized. So yeah, I think we were able to realize a use case in such short time. I think so. Let's wrap it up. As you have seen, Condense doing its job related to data management and also bringing in domain specific intelligence. So you could build a streaming first mobility related application in minutes, actually not in months and weeks together. So whether it's the geofence alerts, whether it's the panic alerts, whether it's ingesting data from telematics devices, or even the telemetry data that is coming from vehicles, Condense offers that backend platform with domain specific intelligence, where you could really facilitate or build a use case which is less time consuming and which actually does the job. Yeah, thanks for joining in, and then let's catch up in the next future coming webinars.